Hi and welcome back. Today I'm going to start working on an auger bit for the blacksmith's brace that I've been working on in the past few weeks. Today I'm actually going to be starting with making the file that I'm going to need to cut the lead screw on this type of an auger bit. This is a modern auger bit, but they really haven't changed much since their invention in the early 1800s. These bits, of course, were the product of the machine age and they were mass produced, so the lead screws on those bits were very accurate and precisely made. However, blacksmiths were called upon to either make drills bits that were an odd size or something that wasn't available locally, or to repair these bits. So on those you started to see quite a difference on the lead screw depending on the skill of the blacksmith. So it's that aspect of making these drills that I want to investigate and experiment with now with these series of videos. The reason I'm starting with making a file to cut this lead screw is because when I started examining photographs of early handmade screws, I began to realize that they were a lot coarser than modern screws. Also, the base of the screw thread tended to be round rather than a sharp V or a squared off V the way modern screws are made. So I'm assuming that a blacksmith making a lead screw for an auger bit would be using a similar type of approach to cut that lead screw. So for that, I need to have a file that has a very different profile from anything that's available today. So the material that I'm going to be using to make the file is just a section of a circular saw blade. These are just those cheap disposable carbide saw blades that you can buy for around 10 bucks. I've cut a section of that, and I've ground in a profile that's basically just a very dull beveled edge like a knife. So there's two bevels on each side, and where they would normally meet to a knife edge, I've ground a flat section, and that's going to carve out the base of the threads, and the two angled sides are going to take care of the sloping sides of the thread. I'm not profiling anything else on this saw blade. I'm going to leave it the full dimension that I have here, and I'm just cutting the teeth where I need them. So this is going to be a very sturdy file that's going to be virtually indestructible, unlike, a needle file, which would be the alternative for doing a job like this. This is actually one of my slotting chisels that I'm turning into a file, so I need to anneal it before I can start cutting in the teeth. So here I've annealed the blank and I've cleaned off the scale with a file and trued up the edges, so I have clean metal to work with. I'm going to be clamping this in a high vise so that I can get a good look at what I'm doing. And this is just my portable vise, and I have it mounted in my post vise, so it's about chest height, and I have my close-up lenses, of course, so I can see what I'm doing. I positioned the blank in the vise so that the beveled edges are just above the top edges of the jaws. This is going to allow me to cut the two side faces first, and then I'll finish the file by cutting the top edge. What I'm doing here is exactly the same as what I showed you in my file making videos, only here I'm using it to cut multiple faces that are going to be doing some cutting, whereas in the file making videos I was just cutting very simple files that only had one cutting face. Once I have the side faces cut, I'm going to trim up the top face with a file, and this is basically just to give me a smooth surface to work on, because when I chiseled in the side teeth, I've created little tiny sharp burrs that are pointing upwards, so I need to clean those off so I don't get hung up on any of those while I'm cutting the teeth. And then once that's done, I cut the top teeth the same way I do everything else. The heat treating is going to be the same as in the other videos. I'm heating it up to a critical temperature and quenching it in oil in this case because the steel that I'm using is an oil hardening steel. And they get used right out of the quench bucket. I don't draw any temper on these at all. And now the moment of truth. You'll notice that I just attached a temporary handle with a pair of vice grips there just to see how this is going to work. So this cross section gives you an idea of how the profile of the lead screw is going to look like. Again, it doesn't have to be pretty to work well, it just has to be pretty if you want to sell it. So as long as the teeth have the correct profile, they're going to cut the steel and give you the results that you want. So next time I'll start working on the actual auger bit now that I know that this file is going to be able to cut the lead screw. Hi, I'm Dennis and thanks for watching. If you're interested in supporting this channel, the simplest way of course is to like, comment, and subscribe. If you have questions and you want to contact me directly, you can do so by emailing me at either one of the addresses that I have listed here. It may take me a couple of days, but I will get back to you. Of course, financial support is always welcome. The only product that I produce is the information contained in these free videos. So if you like the work that I'm doing and the videos that I'm putting out, and you can spare a couple of dollars a month, consider becoming a patron by clicking the orange Patreon logo at the bottom of the screen. Thank you, and we'll see you next time.